Number 1, determine a value of n in simplest form. So in class today, we made up a new number. We made up a number called I, and we defined I so that its square is -1. When you square any real number, you never get -1. You always get a positive, you always get a non-negative number. So we made up this new number I, whose square root is -1. We made up a number whose square gives us a negative number, and it's a very powerful number. This is called the imaginary unit. So in class, we said, wait a minute, this imaginary unit has this interesting cycle when you raise it to a power. So if I want to tackle something like I to the 13, well, we need to know I squared is -1. Well, what's I cubed? Well, I cubed is I squared times I, which is -1 I, which we write as -I. Well, what's I to the 4th? Well, that's I squared times I squared, which is -1 times -1, which is 1. Well, we know that I is just I. And this cycle continues, because I to the 5th is going to be 1 I to the 4th times I, which is 1 times I. So each time you just keep multiplying by another I, and it cycles through this pattern. So I to the 5th is the same as I to the 1st. I to the 6th is the same as I squared, because it's I to the 4th, which is 1, times -1, which is I squared. So it's this pattern that cycles through, and we care about the remainder when we divide by 4. So when I divide 13 by 4, the remainder is 0.25, which is a remainder of 1. So that becomes I to the 1. 18 divided by 4, use your calculator if you have to. 18 divided by 4, well, that's 16 plus 2. So I get 0.25 as a remainder. I get a remainder of 2. So that's I squared. I to the 31st, I can keep taking groups of 4. 4, 8, 12, 16, 20, 24, 28. So I have a remainder of 3 here, so that's plus I to the 3rd. Well, I to the 1st is I. You have to know I squared is -1. That is the biggest idea when we work with complex numbers. I cubed, you should know that I cubed is -I plus n equals 0. So I minus I adds to 0. -1 plus n equals 0. N has to equal 1. So this question just had us thinking about those powers of I. The key thing here is it's the remainder when you divide by 4. That power, because we have that cyclical nature here, it's the remainder when we divide by 4. That's what that new power becomes. So when I add a real number to an imaginary number, we get what's called a complex number. And we write complex numbers in the form a plus bi, where a is the real part and b is the imaginary part, the coefficient of I. So we basically treat them as variables. We basically treat these complex numbers as we would any x that we see, but we use the relationship I squared equals -1, because that's how we defined I. We defined I to be the number whose square is -1. So for example, to add these two complex numbers together, you do the real part, 1 plus 1 is 2, and then you do the imaginary part, just as if you combine like terms. I minus I gives you 0. So you get the number 2. To multiply complex numbers, well, they're binomials, so I'm going to make a table. 1 plus I, 1 minus I. 1 times 1 is 1, I times 1 is 1I, 1 times -I is -1I times -I is -I squared. So I get 1 plus I minus I squared. Those add to 0, so I get 1 minus I squared. But we know that I squared is -1. So I get 1 minus -1, which happens to also be 2. All right, so I need to multiply these two complex numbers first. I'm going to make a table, and then I need to distribute here. So you could make a table here and get what? So let's see. 1 minus I, 2 minus 3I. 2 minus 2I minus 3I. So I had negative, so that's a positive 3I squared. So I end up with 2 minus 5I plus 3I squared. Distributing now 3I minus 3I squared. Whenever we see an I squared, it's really negative 1. So 3 times negative 1 is negative 3. Make that substitution whenever you see higher powers of I. I squared is negative 1, so negative 3I squared is really positive 3. So my final answer comes out to be 2 minus 2I. How do I square 3 plus I? Well, you square it like we square anything else. You make a table, or use that little pattern of square the first, 2 times their product, square the last. So I get 9, 3I, 3I, I squared. So I get 9 plus 6I. But wait a minute, I squared is negative 1. Then I have to distribute here. Minus 18 minus 6I. So I'm left with what? I'm left with 9 minus 18 is negative 9. Oh, I got a minus 1 there too. So 9 minus 19 is negative 10. Those add to 0, so I'm left with the real number, negative 10. Why do we care about these complex numbers? We care about these complex numbers because they're going to help us solve every single quadratic equation now. Before, sometimes we gave up when we solved quadratic equations because we ended up with square roots of negative numbers. But we don't need to worry about that anymore. So find the solutions to x squared minus 4x plus 13 equals 0. So before this lesson, whenever we solved a quadratic, we tried to factor it. We'd ask ourselves, what multiplies to 13? That adds to negative 4. Well, what multiplies to 13 is pretty straightforward. 1 times 13. There's no way I'm getting 4 from both of those numbers. So this polynomial here is not factorable, which means we have to use the quadratic formula. So right now, I know you're singing in your head, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where in this trinomial it's set equal to 0, a equals 1, that's my leading coefficient, b equals negative 4, c equals 13. So my solutions are x equals the opposite of b plus or minus the square root of b squared. Well, negative 4 squared is 16 minus 4ac all over 2 times 1, which is 2. Then you type in your calculator 16 minus 4 times 1 times 13 and get 4 plus or minus the square root of 16 minus 52 over 2. Keep on going. Well, 4 plus or minus the square root of negative 36 over 2. And back in Algebra 1, at this point, we would panic. We would say, we have a negative under our radical. But wait a second. We know how to deal with that now. Because I squared equals negative 1, I equals the square root of negative 1. I equals the square root of negative 1. So we can split this radical apart as negative 1 and 36. So I get I times 6. So the square root of negative 36 we write as the number now called 6i. So making that substitution, I have 4 plus or minus 6i over 2, which makes my solutions to this quadratic equation 2 plus or minus 3i. There are these complex numbers. 2 plus 3i is one solution, and the other solution is 2 minus 3i. Those are my solutions to this quadratic equation. Back before we had the imaginary number I, we would have to give up and quit at this point. But we don't have to quit anymore because we can deal with a negative inside our radical because we defined I squared as a number whose square root is I is the square root of -1. So we now have complex number solutions to quadratic equations.